Jai Hind and good morning, students. Yesterday we had completed the charge and the amount of charge. Today I am going to discuss about the next topic, that is potential and potential difference. Potential, the general meaning of the potential, you may understand that if you keep on taking the electrons out of a substance, of an atom, the amount of potential is increasing. First thing, as soon as it starts losing electron, a substance, collection of number of atoms, and if you keep taking electrons out, it means it is getting gradually more positive charge. So as soon as you start taking the electrons from a substance, the positive character of the substance starts increasing when it becomes highly more positive, and you may say that its potential is increasing. Because as soon as you start taking the electron out, what happens? To attract the electrons, its property increases. More positive it is, more electrons will be attracted towards it. So first thing we must know that if I am talking about the potential, so if I am talking about the high potential actually. So a high potential means if you keep on taking electrons from out from a substance, it will start increasing in potential. Start increasing potential means it will have now more tendency to attract the electrons. And once it has started taking electrons, then you can say that it is having some potential. Is that clear? Here I have taken a positive charge, and as you know that every magnet is having a magnetic field around it. Okay, in the same manner every charge is having electric field around it. Okay, and suppose this circle is showing the electric field of this charge Q, a heavy charge I have taken here. And the second charge, this is the test charge, okay, and it is coming from infinity to electric field of the given charge. Why will it come? Because it is positive. It is positive, there must be repulsion. It will never come to this charge Q. Then some external force. Suppose if I am taking this charge from infinity to a point inside the electric field of this charge, you will agree that we will have to do some work or not. Why? Because there is a force of repulsion going on, and this charge is trying to push this charge away from it. But you are taking the charge from infinity to a point in an electric field of this charge. Then definitely you have to do some work. Suppose if the charge is being brought from infinity to a point in an electric field of a charge, then the work done is W. And how much charge you are taking? Q. Q is coulomb of charge. Yesterday I had discussed this thing. Q means Q is equal to Ne. It is the collection of n number of electrons. Is that clear? So suppose if you are, since Q charge is doing the work W to come an electric field, then what will be the work done by the 1 coulomb of charge? You can see that it will become W upon Q, and this is so called potential. So what is potential? Potential is the work done in bringing a charge, unit positive charge, from infinity to a point in an electric field. Again I am repeating it. What is potential? Potential, it is the work done by unit positive charge bringing it from infinity to a point in an electric field. Then the formula becomes V is equal to W upon Q, where W is work done. If you are having a pen and paper, you can note it down also. W is the work done by the charge, and Q is the amount of charge. And if you are dividing the work done by charge, then you are getting the potential. More the work done, more potential. So V is directly proportional to W. Is that clear? If the potential is high, it means charge has to do more work. Suppose if I ask you, there is a cell of 1.5 volt and there is a cell of 9 volt. In which the work done is more? Of course in the 9 volt, because 9 volt means 9 joule per coulomb. Here 1 coulomb of charge is doing the work of 9 joule. And in 1.5 volt cell, 1 coulomb of charge is doing the work of 1.5 joule. So V is equal to W upon Q. And what is joule upon coulomb? Joule upon coulomb is the unit of potential, and it is also known as in SI unit volt. Volt is the unit of potential. But suppose if a charge is moving in an electric field from one point A to B, say, then here the potential will be more because distance is decreasing, so work done will be more. At V2, at point this, suppose B, and this is point A. So here at B potential is more, and at A potential is less because it is having more distance. So at that moment, suppose potential is V2 here and here V1, then the V2 minus V1 is equal to W upon Q. So this will become potential difference. So how will you define potential difference? Potential difference means it is the amount of work done moving from one point to other point in an electric field. Then the work done by the unit positive charge is known as potential difference. So if the charge is being brought from infinity to a point, it becomes potential, and when it is moving an electric field from A to B, then it is known as potential difference. It is clear? Okay, thank you.